Welcome back to the deep dive. Okay, today we're tackling something pretty huge. The quest to understand the very fabric of the universe.
Yeah, it's a big one. We're comparing two really different ways people have tried to define reality.
On one side, we've got Nikola Tesla, the visionary, the inventor, often wrapped up in myth.
Right, with his focus on energy, frequency, vibration things, he saw almost as engineering tools.
And on the other side, we've got modern physics, specifically string theory. Super cutting edge, highly theoretical.
It suggests everything is made of these tiny, tiny vibrating strands of energy. It's a framework built really on abstract math and the idea of extra dimensions.
So it's a journey through history, some pretty dense physics, even a bit of esoteric thought. We'll be looking at historical accounts, texts like the Kabbalion, and the complex math behind things like M-theory.
And the mission for you, listening in, is to see where these very different approaches overlap, surprisingly, and where they just fundamentally diverge.
And the idea guiding us, the thread running through it all, is that famous Tesla quote.
Yes. If you want to find the secrets of the universe, think in terms of energy, frequency, and vibration. Let's start right there. What did he actually mean by that?
Okay, this trio. Energy, frequency, vibration. For Tesla, these weren't separate ideas, were they?
Not at all. He saw them as completely intertwined, like threads weaving together reality. He called it the symphony of existence, which is quite poetic.
Let's break them down. Energy first.
Right, energy. For Tesla, energy was just everything, the absolute essence. And he was a firm believer in the law of conservation of energy.
Can't be created or destroyed, only changes form.
Exactly. And this wasn't just physics for him. It had like cosmological implications. If energy is eternal and just keeps transforming, then everything in a sense already exists, meaning all things are fundamentally immortal, existing in this energetic, vibrating state. What we perceive as solid matter is just one temporary shape this eternal energy takes.
Okay, so energy is the stuff. What about frequency?
Frequency is how it's organized. It's the rate of vibration, cycles per second. Think of it like the language of the universe.
How so?
Well, frequency determines the pitch of a sound, right? Or the color of light. Tesla believed it also determined the specific patterns that make matter stable. Everything from tiny particles to huge cosmic structures, what he sometimes called the cosmic comb, communicates and syncs up through frequency.
It's like a universal tuning fork.
Sort of, yeah. A set of underlying frequencies that structure everything.
Which brings us to vibration. This is the more tangible aspect.
Correct. Vibration is frequency made physical. It's the actual oscillation, the back and forth movement. And we even use this idea informally, don't we?
Like getting a good vibe or bad vibe.
Exactly that. Tesla saw that intuition as fundamentally physical. If something exists, it vibrates at a certain frequency, and that dictates its properties.
It's interesting how these abstract ideas become very concrete in biology. You mentioned the human heart.
Oh, the heart's a fantastic example. It's not just pumping blood, it's a powerful electrical generator.
Yeah.
Seriously powerful.
It creates a magnetic field.
A big one. A 360-degree field you can measure about 3 feet away from the chest. That field is the vibrational result of the heart's electrical frequency.
And when that rhythm goes wrong, like an arrhythmia,
We use a defibrillator. And what does it do? It delivers a massive electrical shock.
not to restart it though, right?
No, exactly. It's to stop the chaotic, random vibrations. It forces everything to halt for a split second so the heart's natural pacemaker can hopefully reestablish that coordinated rhythmic beat. It's all about electrical coordination.
This coordination, this energy transfer
Yeah.
that leads us to resonance.
Yes, resonance was absolutely key for Tesla. It's when you have one thing vibrating and it makes another thing start vibrating at the same frequency.
And the energy can build up massively.
Hugely. It's like pushing a swing. Time it right. And with tiny pushes, you get a huge arc. That's resonance. Amplification through sympathetic vibration.
And this idea had some, well, pretty traumatic applications, even in healing. Thinking of Dr. Royal Raymond Rife.
Rife's work in the 20s and 30s is controversial, definitely, but fascinating. He claimed he could cure diseases using resonance. He built this incredibly powerful microscope, the universal microscope, and claimed he could see living viruses and bacteria, which was difficult back then. He believed each pathogen had a unique vibrational frequency, its own note, if you will.
Like the wine glass and the opera singer.
Exactly that analogy. Rife claimed he could beam plasma rays tuned to that exact frequency at the pathogen. The idea was the resonance would build and build until the organism literally vibrated itself apart.
Shattering the disease.
That was the claim. He reportedly cured 16 terminally ill cancer patients this way. Of course, this work was heavily suppressed and disputed later, but the principle of resonant destruction is sound physics.
For Tesla, this power wasn't just for healing. It was about physical manipulation, too. Which brings us to the infamous earthquake machine.
Right, the legend. He wasn't actually trying to cause earthquakes, but more demonstrate the principle of resonance. He patented a steam-powered oscillator in 1893.
Just a small device.
Relatively small, yeah. The story goes that in 1898, he attached a later version, supposedly tiny, like pigeon wing size, to a steel beam in his lab.
And
He tuned it, it found the resonant frequency of the beam, then the building, then supposedly the ground beneath Manhattan. The vibrations got so intense, instruments fell, plaster cracked, and people panicked. Police were called.
he claimed he could have brought down the Brooklyn Bridge in an hour with it.
That's the claim. Whether it's entirely true or exaggerated, the point was made.
Oh.
Find the right frequency, apply even a small rhythmic force, and you can unleash incredible power. Resonance amplifies everything.
Okay, so we have these amazing stories, these powerful ideas about vibration and resonance. But the history around Tesla, it's complicated. There's a lot of myth mixed in.
Oh, absolutely. To really grasp his theories, we kind of need to clear away some of the popular misconceptions first, especially around the War of the Currents.
Right, the classic story, Tesla, genius inventor of AC, versus Edison, clinging to DC.
Yeah, that narrative gives Tesla maybe a bit too much credit for inventing AC itself. It oversimplifies the whole thing.
So let's set the record straight. Tesla did not invent alternating current.
No, he didn't. The basic principles were known long before him. You've got to go back to Michael Faraday's work on induction, which inspired Hippolyta Pixii to build the first AC generator way back in 1832.
1832, okay.
Pixii actually used brushes to immediately convert it to DC, but the alternating principle was there. And people were using AC lighting systems by 1856, the year Tesla was born.
So what was Tesla's big contribution to AC?
It was the polyphase AC system, particularly the efficient induction motor. That was the breakthrough that made AC practical for power transmission over long distances. That was his genius.
But even there, was he the only one working on it?
No, and this is important. We need to acknowledge Galileo Ferraris in Italy. Yes. He independently developed a working polyphase AC system and motor in 1885. His motor wasn't very efficient initially, but Tesla himself admitted they'd arrived at the same theoretical results completely independently.
So, parallel invention. It happens.
It does. Tesla's system was ultimately more robust and commercially viable, but Ferrari's was definitely there first with the concept demonstration.
Okay, so the invention part is more nuanced. What about the war itself? Was it really Edison versus Tesla?
Not primarily. The real battle, the financial and industrial war, was between Thomas Edison championing DC and George Westinghouse, who was betting heavily on AC.
Where does Tesla fit in?
Tesla became a factor after 1888 when Westinghouse bought his polyphase motor patents. Westinghouse needed that motor to make his AC system truly competitive for industrial power, not just lighting.
And Westinghouse was already pushing AC before Tesla's motor.
Oh, yes. The invention of the efficient transformer around 1885 had already made AC far superior for long-distance transmission. Westinghouse saw the future. Edison saw his DC empire threatened.
And Edison fought dirty, didn't he?
Yeah. Absolutely brutal. He launched a massive smear campaign, publicly electrocuting animals, dogs, cats, even an elephant eventually using AC to prove how dangerous it was.
Horrific.
And he lobbied hard for AC to be used in the first electric chair, specifically hoping people would call it being Westinghoused. He wanted to associate his rival's technology with death.
So Tesla was important for his patents, but Westinghouse was the main opponent to Edison.
Exactly. Westinghouse was the industrialist fighting the war. History has kind of recast it as this epic Edison versus Tesla duel, largely erasing Westinghouse, which isn't quite accurate.
And ironically, who ended up pushing Edison out?
J.P. Morgan, the financier. He eventually forced a merger that created General Electric, sidelined Edison, and embraced AC because ultimately it was just better and cheaper. Economics won.
Okay, let's move to Wardenclyffe, the giant tower. The myth there is often about free energy, right?
That's a popular idea. Tesla wanted to give the world free energy, and the greedy bankers, particularly J.P. Morgan, who funded it initially, shut him down.
But that wasn't quite his plan.
No. Tesla wasn't proposing free energy like pulling power from nowhere. His idea was about cheaper transmission. He wanted to use the Earth itself as a giant conductor.
Send power wirelessly through the ground and air.
Precisely. To bypass the need for expensive copper wires and power grids, it was about distribution cost, not violating thermodynamics.
But even with that clarified, his later theoretical work faced criticism, didn't it?
It did. While he was an unparalleled electrical inventor, especially earlier in his career, his grasp on fundamental physics, particularly later on, was, well, shaky, according to his peers.
Like what?
His physics was described by some contemporaries as demonstrably horrible. He clung to older ideas. He didn't believe in the existence of electrons, for instance.
Really? No electrons?
Nope. He dismissed Einstein's relativity as pseudoscience. He even denied that radio waves, as discovered by Hertz, were actually electromagnetic vibrations traveling through space. He had a different model entirely based on the ether. We'll definitely get back to that. But it shows a kind of scientific conservatism clashing with his radical engineering ideas.
And this perhaps shows up in how he got Wardenclyffe funded. The pitch to Morgan.
That's a fascinating example. He wrote an article in 1900 to convince J.P. Morgan to invest a huge sum, $150,000 back then.
And the article was?
Critics at the time said it swapped rigorous science for spectacular sensationalism. And the weirdest part, it contained only one mathematical equation.
Okay.
In this equation, the variable m for mass wasn't physical mass. Tesla defined m as the mass of mankind.
The mass of mankind.
Yes. And he claimed this mass could be improved by, quote, promotion of marriage and attention to hygiene.
That's not physics.
Not even close. It sounds more like some kind of a social cosmic manifesto than a serious scientific proposal. It really highlights the unconventional, sometimes non-scientific paths his thinking took later on.
Okay, so despite those later theoretical issues, there's one concept Tesla clung to his entire life, and it's the key link to where physics is today: the ether.
Absolutely. Tesla never gave up on the ether. For him, it was fundamental. It wasn't just empty space. It was a substance, an undifferentiated field filling everything.
The medium for everything.
Exactly. It connected all matter. It transmitted forces like gravity and light. It explained action at a distance. He thought abandoning the ether, which Einstein's relativity seemed to do, was a huge mistake. A step backward for science.
And this belief shaped his view of light itself, putting him at odds with mainstream physics.
Completely at odds. Physics describes light as a transverse electromagnetic wave. It wiggles side to side as it travels. Tesla rejected that.
What did he think it was?
He insisted light was a longitudinal wave in the ether, like a sound wave compressing and expanding the medium as it travels forward. Think of pushing a spring.
So for him, the speed of light wasn't constant, but depended on the ether.
Yes, on the ether's density and elasticity, just like the speed of sound depends on air pressure and temperature. This directly contradicted Einstein's core postulate of special relativity.
Did he claim to have proof?
He did. In 1896, he developed a new kind of vacuum tube. When he ran high-frequency currents through it, even with a near-perfect vacuum inside, he saw this purplish glow, a coronal discharge extending several feet outside the tube.
And he interpreted this as
proof of the ether. He argued that for this discharge to happen in such a high vacuum, there must be a medium still present, made of particles much, much smaller than air molecules. That medium, for him, was the ether. It confirmed his belief.
He was absolutely convinced.
Not unshakable on this point.
It's fascinating, though, this deep conviction that reality is built on some fundamental vibrating medium. It weirdly echoes the biggest challenge in physics today, doesn't it?
It really does. That search for a unifying medium or framework is exactly what drives things like string theory.
Okay, let's dive into string theory. What's the basic problem it's trying to solve?
The absolute biggest problem. Reconciling general relativity, Einstein's theory of gravity, which governs large scales, with quantum mechanics, which rules the tiny world of particles.
They don't play nicely together.
Not at all. They give nonsensical answers, infinities, when you try to apply them both in extreme situations, like inside a black hole or at the Big Bang. They're mathematically incompatible as they stand.
So string theory's solution is?
Radically change what we think particles are. Instead of seeing them as zero-dimensional points, like little dots, string theory says the fundamental constituents of reality are tiny one-dimensional vibrating loops or strands of energy, strings.
Okay, hold on. Everything, electrons, quarks, photons, everything is made of these tiny strings. How tiny are we talking?
Incredibly tiny, like 1035 meters, that's the Planck length. far, far smaller than anything we could ever hope to see directly.
And how do these identical strings create all the different particles we observe with different masses, charges, spins?
Through vibration.
Mm.
Just like a violin string can produce different notes depending on how it vibrates, these fundamental strings can vibrate in different patterns, different modes.
And each vibration pattern corresponds to a different particle.
Exactly. One pattern vibrates as an electron, another as a quark, another as a photon. It's the music of the string that determines the particle properties.
And crucially, this includes gravity.
Yes, this is key. One specific vibrational mode of the string naturally corresponds to the properties predicted for the graviton, the hypothetical quantum particle that carries the gravitational force.
So string theory automatically includes quantum gravity, which is the big hurdle.
It inherently provides a framework for it, yes. That was one of its first major selling points.
But this framework comes at a price, dimensionally speaking.
A big price.
Yeah.
Our familiar reality has 3 spatial dimensions plus time, 4 space-time dimensions. For the math of string theory to work, to be consistent and avoid those paradoxes,
It needs more.
it needs many more. Superstring theory, the main versions, require 10 space-time dimensions, and the overarching framework, M theory, needs 11.
11 dimensions. Where are the other 6 or 7 spatial dimensions? I'm not seeing them.
Right, you wouldn't. The idea is compactification. These extra dimensions aren't large and extended like the 3 we experience. They're curled up incredibly tightly at every single point in space.
Curled up. Like how?
Imagine a garden hose. From far away, it looks like a one-dimensional line. But get close, and you see it has a second dimension, the circular circumference, curled up and tiny. The extra spatial dimensions in string theory are thought to be curled up like that, but in much more complex shapes.
And the shape matters.
Immensely. The specific geometric shape of these curled-up dimensions, often visualized as complex structures called Calabi-Yau manifolds, is what determines the physics we see in our large dimensions.
Wait, the geometry of the hidden dimensions dictates things like the mass of the electron or the strength of forces.
Precisely. The fundamental laws of nature, the constants we measure, are supposedly encoded in the geometry of these compactified dimensions. It's a profound link between geometry and physics.
Mind-bending. Okay, and you mentioned M theory, the unification of different string theories.
Yes. In the mid-90s, physicists realized there were 5 consistent versions of superstring theory. They looked different.
Type IA, IIB.
Those ones, plus 2 heterotic types. But then, through work by people like Edward Witten, they realized these 5 theories weren't truly separate. They were like different perspectives, different limiting cases of one single underlying theory in 11 dimensions.
And that's M theory. What does the M stand for?
Witten famously kept it ambiguous. Could be magic, mystery, or perhaps most significantly, membrane.
Membrane. Why membrane?
Because M theory doesn't just contain one-dimensional strings, it also includes higher-dimensional objects called branes, short for membranes. These can be 2D planes, 3D volumes, or even higher-dimensional surfaces that strings can end on or move within. Recognizing branes was a huge step.
Okay, the math gets even weirder here, right? This idea of duality seems central to M theory.
It's absolutely fundamental and intellectually, well, startling. Duality is when you discover that 2 physical theories, which look completely different on the surface, are actually mathematically identical.
Describing the same reality using different languages.
Exactly. It's like finding out that, say, a theory describing waves crashing on a beach uses the exact same equations as a theory describing heat flowing through metal. They're just different manifestations of the same underlying mathematical structure.
What's an example in string theory? S-duality.
S-duality is a really powerful one. It relates the strength of interactions. It can show that a theory where particles interact very strongly, which is usually incredibly hard to calculate, is actually mathematically equivalent to a different theory where the particles interact very weakly.
Strong equals weak. How does that work?
It means if you have a tough problem in the strongly coupled theory, you can use the duality mapping to translate it into the weakly coupled theory, solve it easily there, and then translate the answer back. The math guarantees the result is correct. It's like a cheat code provided by the structure of the theory itself.
Okay, that's wild. And the other big one, T-duality, involves size.
Yeah, T-duality is maybe even stranger. It relates to the size of those compactified dimensions we talked about. It says that a string moving on a small, curled-up circle of radius rollers is physically indistinguishable from a string moving on a large circle of radius dollars.
So a tiny dimension is the same as a huge dimension.
Physically, yes. If you imagine one of those extra dimensions is curled up to be, say, a billionth of the Planck length, incredibly tiny r, the physics described by the theory is identical to if that dimension were curled up to be 1,000,000,000 times the Planck length. Huge 1r.
The theory can't tell the difference between large and small scales in that context.
Exactly. It fundamentally challenges our intuitive notions of size and distance at the most basic level.
This abstract mathematical power, these dualities,
Mm.
they actually led to one of string theory's biggest successes, didn't they? Solving the black hole information paradox.
Yes, this was a massive breakthrough in the mid-90s. The background is the Wittgenstein-Hawking formula from the 70s.
Which said black holes have entropy proportional to their surface area.
Right. Sum of the dollars is proportional to 8. Entropy usually measures the number of internal microstates, the ways the system can be arranged internally. But if stuff falls into a black hole, it seems lost forever. So where are the microstates? Does the black hole just destroy information, violating quantum mechanics? That was the puzzle.
And string theory provided the microstates.
Strominger and Vafa did in 1996. They looked at specific types of extremal black holes and modeled them using string theory components, specifically as complex configurations of D-branes.
Those higher dimensional membranes.
Exactly.
Yeah.
They treated the black hole as a dense tangle of D-branes and strings. Then, using the rules of string theory and quantum mechanics, they counted the number of possible ways you could arrange those branes and strings to get the mass and charge of that specific black hole. They counted the microstates.
And the number they got.
When they calculated the entropy based on that count, it exactly matched the Wittgenstein-Hawking formula, including the crucial factor of 14. It was perfect. It was stunning. A calculation from microscopic string theory reproducing a result from macroscopic general relativity. It was the strongest evidence to date that string theory was on the right track for unifying gravity and quantum mechanics.
That convergence of the micro and macro, it brings us back, maybe surprisingly, to some older philosophical ideas, like those in the Kybalion.
It's an interesting parallel. The Kybalion popularized these 7 Hermetic principles, supposedly ancient wisdom, though the book itself is early 20th century. We're not saying it's literal ancient truth, but the principles themselves frame these modern physics concepts remarkably well.
Like the principle of vibration.
Nothing rests.
Yeah.
Everything moves. Everything vibrates. I mean, that's the core idea for both Tesla, with his cosmic resonance, and string theory, where particles are vibrations. It's fundamental to both worldviews.
And the principle of correspondence.
As above, so below. As below, so above. This perfectly captures the entire motivation for unifying general relativity, the above, large scales, and quantum mechanics, the below, small scales. The search for universal laws.
Makes sense. And polarity.
Everything is dual. Everything has poles. That resonates incredibly strongly with the discovery of dualities like S-duality and T-duality, where seemingly opposite concepts, strong-weak coupling, large-small radius, are revealed as two sides of the same coin.
It's almost eerie how these century-old philosophical axioms seem to prefigure the abstract mathematical discoveries of recent decades.
It's quite striking.
But string theory faces a huge philosophical hurdle. Maybe its biggest challenge.
Yeah.
The sheer number of possible universes it seems to predict. The string theory landscape.
Yes, the landscape. This is the elephant in the room. Remember how the shape of the extra dimensions, the Calabi-Yau manifold, determines our physics?
Yeah.
Well, it turns out there isn't just one possible shape. The mathematics allows for an absolutely vast number of stable shapes, or vacuum states.
How vast?
The estimates are astronomical, something like 10,500 possible stable vacuum states. Each one corresponds to a different universe with potentially different physical laws, different constants of nature.
10 to the 500. That's practically infinite. So the theory predicts basically any kind of universe is possible.
That's the criticism. People like Peter White argue that if the theory can predict anything, it predicts nothing specific about our universe. It becomes untestable, unfalsifiable. If any experimental result could be explained by just picking the right vacuum state at a $1,000, is it still science?
That's a powerful critique. How do string theorists respond? People like Leonard Susskind.
They often invoke the anthropic principle. The argument goes, yes, there's a vast landscape of possibilities, but we could only exist in a universe whose laws and constants are compatible with the evolution of life.
So we find ourselves in a universe with, say, a very small cosmological constant, because if it were much larger, galaxies wouldn't have formed and we wouldn't be here to observe it.
Exactly. The landscape isn't a bug, it's a feature, they argue. It provides the necessary backdrop for the anthropic principle to explain why our universe has the specific, seemingly fine-tuned properties it does. We live in one of the rare habitable corners of the landscape.
It shifts the goal from predicting our universe uniquely to explaining why we observe the specific physics we do within a much larger multiverse of possibilities.
Okay, let's shift back to Tesla one last time and look at some of his most out there ideas, particularly about time. His view was completely different from Einstein's.
Einstein saw time as relative, interwoven with space into space-time. But
Tesla saw time as something much more substantial, not just a way to order events, but a real algorithm of materialized mathematics. He even theorized that matter itself wasn't fundamental, but emerged from the ether because of what he called time resonance between physical systems.
time resonance creates matter. That's radical.
Extremely. And it led him to equally radical ideas about motion. He claimed motion is a result of asynchronism.
Asynchronism, meaning things being out of sync in time.
Yes. Differences in time cycles, or phase shifts. He believed you could change an object's velocity or even its mass without applying an external force, simply by manipulating its time cycle relative to its environment. He claimed his own rotating magnetic field experiments already proved this.
So altering time phases could cause acceleration.
That was his controversial idea. He thought all rotation in the universe, from electrons spinning to galaxies whirling, followed the same principle as his induction motor, phase shifting. A single, simple law governing all cosmic motion.
Sounds like he viewed the universe as a giant electrical machine to be engineered.
Very much so. And this connects to his experiments with extremely low-frequency ELF waves.
You mentioned the Earth's natural frequency, the Schumann waves.
Right, around 7.8 hertz.
Yeah.
Tesla experimented with these frequencies. He believed that if you could achieve perfect resonance with the Earth's electromagnetic field, you could transmit signals, maybe even power, instantaneously.
Faster than light.
Yes, because it wouldn't be radiation traveling through space, which is limited by light speed. It would be resonance, the entire system oscillating in sync, instantaneously, like coupled pendulums.
And this grand vision of global resonance, that was the real goal behind Wardenclyffe.
That seems to be the case. Wardenclyffe wasn't just meant for wireless communication or power. It was the centerpiece of his ambitious worldwide system. He had these 12 stated goals.
Which aimed to do what?
Essentially, to transform the entire globe into a sentient being. He wanted to link the Earth, the ionosphere, the atmosphere, everything into one single synchronized resonant structure.
The potential applications he envisioned were staggering.
Completely. The sources suggest he thought he could draw energy directly from the ether by manipulating non-resonant electromagnetic fields using time shifting.
And even stranger claims.
Well, there are accounts suggesting he believed the system could open temporary windows to parallel worlds by hitting specific harmonic frequencies.
Parallel worlds.
That's the claim. Also, the idea of accelerating human evolution by bathing the planet in a permanent high-frequency field to enhance our sensibility and ability to receive ideas directly from the cosmos.
It sounds like science fiction.
It borders on it. And the most extreme, unverified claim is that a network of 5 Wardenclyffe-type towers operating in perfect resonance could somehow shift the entire Earth into a parallel reality.
Physically move the planet.
By manipulating its resonant state within the cosmos. It's unclear how serious he was about that, or if it was hyperbole.
What happened to Wardenclyffe in the end? He got it running.
He tested the massive transmitter in 1903. Reports described incredible electrical displays, glaringly bright strands of electrical plasma lighting up the sky for miles. But then, suddenly, in 1905, he just abandoned it, walked away.
Why? Funding dried up.
That was part of it. Morgan pulled out after realizing it wasn't just for radio. But Tesla also left all his notes, calculations, drawings right there. It's still a mystery why he stopped so abruptly after getting it operational.
And the mystery deepens after his death.
Yes. When he died in 1943, the FBI supposedly confiscated many of his papers and research equipment. Much of it has never surfaced publicly.
Which fuels conspiracy theories.
Exactly. Including the persistent, though completely unconfirmed, link between Tesla's high-energy plasma experiments and the alleged Philadelphia experiment.
Where a U.S. Navy ship supposedly turned invisible or teleported.
That's the legend. Preceded, supposedly, by a thick greenish fog, which sounds eerily similar to descriptions of the high-energy plasma discharges Tesla was creating. Again, no proof, but the legend persists because of the missing papers and the nature of his later work. #tag outro.
So we've journeyed through 2 vastly different attempts to grasp the universe's secrets. Tesla, the hands-on inventor, seeing reality governed by energy, frequency, and vibration in a tangible ether.
And modern physics, with string theory, arriving at vibration through pure mathematics, describing particles as vibrating strings in extra dimensions, seeking unification through geometry and duality.
Separated by nearly a century, different tools, different languages, but both fundamentally landing on vibration is the key. Tesla through electromagnetic resonance, physics through mathematical resonance in higher dimensions.
It's this incredible convergence on the idea that the universe is, at its heart, rhythmic, resonant, vibrational.
It really leaves you wondering, if string theory's landscape is real, with its 10,500 possible universes,
Each just a different vibration allowed by the underlying mathematical structure.
and if you combine that with Tesla's idea of cosmic resonance determining reality, what does that imply?
It leads to a pretty profound final thought for you, the listener, to ponder.
Is the reality we perceive, the particles, the forces, the laws of physics that seem so solid, is it just one specific note being played? One frequency selected, perhaps anthropically, from an unimaginably vast orchestra of mathematical possibilities?
And if our physical laws are just echoes of a deeper geometric harmony, one tune chosen from 10,500 options, what does that really mean for things like free will or our place in the cosmos? Are we just living out one possible vibration?